Good morning guys, welcome to Mind Your Math. As you can see, today our class is on circumcenter of triangles. Now, we will be discussing about circumcenter and I would like to tell you that this particular class is divided into three parts. Now, the first part we will be talking about the definition of a circumcenter, a few properties of the circumcenter as related to triangles and a few terms associated with circumcenter. In the second part, we will be doing a few sums with respect to circle and triangle geometry. So our basic focus will be on the circumcenter and we will be doing sums on circumcenter as related to triangle and circle geometry. In the third part, I will be introducing the concept of coordinate geometry with respect to circumcenter. Now, if you have any doubt in any of the concept that is being discussed in the class, please feel free to mail me at the mail ID given below in the description box. Okay, now let us start our class. So, before we start the class, there are a few terms that you should already be familiar with when you are starting the concept of circumcenter. The first one, it is very obvious, a triangle. A triangle is a closed figure made up of three straight lines. Now, the concept of perpendicular bisector. So, what is a perpendicular bisector? Perpendicular bisector is a line that divides any other given line into two equal parts and at an angle of 90 degree. A bisector is a line that divides a line into two equal parts. A perpendicular bisector will divide a line into two equal parts at 90 degree. Concurrent lines. So what are concurrent lines? Concurrent lines are lines that pass through a single point. So I can have 5 concurrent lines. So they all should pass through the same point. Such lines are, so I can say that these 5 lines are concurrent and they meet at the common point. Let us name it as an O. So such lines are called as concurrent lines. So these three terms are, you need to understand the concept of these three terms before we move on to the concept of circumcenter. Here you have a triangle ABC. So it can be an acute triangle or an obtuse triangle. It can be a scalene triangle or an equilateral or an isosceles. It doesn't matter. It is just a triangle ABC. And I have the perpendicular bisectors of the sides AB, BC and AC here. I have drawn them using orange lines. Now you can see that these three lines meet at a single point. This particular point is called as a circumcenter of a triangle. Now, this particular point is unique, which means that every triangle, the perpendicular bisectors will meet only at one point. So, a triangle cannot have multiple points of circumcenter. This particular circumcenter for any triangle is a unique point. Okay? I have a triangle here. You can see that I have enclosed a triangle within a circle. You can see that all the vertices of the triangle, they are touching the circumference of the circle. These are the perpendicular bisectors and they are meeting at a common point O, which we have already discussed is called as a circumcenter. Right? Now, before we move on to the properties of a circumcenter, let us first discuss what is a cyclic figure. Whenever I have a polygon of any number of sides, a polygon is a closed figure made up of straight lines. So whenever I have a polygon which can be enclosed within a circle in such a way that all the vertices are touching the circumference of the circle, it is called as a cyclic polygon or a cyclic figure. So suppose I have got a polygon like this. So I have got 2 plus 2 plus is a 5-sided polygon which is a pentagon. I am drawing a circle in such a way that it is touching, it is not a proper circle, but then yeah, it is touching all the vertices of the polygon. I can say that this particular pentagon is a cyclic pentagon, right? Suppose I am missing this one vertex, but all the 4 vertices are touching the circumference. Then it is not a cyclic polygon, right? Now, by default, all triangles are cyclic, which means that all triangles can be enclosed within a circle irrespective of the size or the type of the triangle. Now you know that whenever you have a circle, it has to have a center, right? So this particular circle also should be having a center. That particular center is given by the circumcenter of the triangle. and this particular circle inside which the triangle is inscribed is called as a circumcircle. So this triangle, this circle is called as a circumcircle, right? This particular point, as we have already discussed, is called as a circumcenter. Okay. Now you have a circle, you have a center. Now I need a radius. Okay. So the distance of any circle from the center to the circumference is called as a radius. To any point in the circumference is called as a radius. So the distance from here to here. This is my radius. This is my radius, and this line is also my radius. OA, OB and OC are the measures of the radius of the circle. All of them has to be equal because the radius of a circle is again unique. It has only one value. So OA is equal to OB is equal to OC. So we have a circumcenter, we have a circumcircle, we have a circumradius, right? So we have figured out OA, OB and OC are circumradius. Now OBC is a triangle. OB is equal to OC. When two sides of a triangle are equal, such a triangle is called as an isosceles triangle. So OBC is an isosceles triangle, OAC is an isosceles triangle, and OAB is an isosceles triangle. So basically, my circumcenter and the circumradius is dividing that entire triangle into three isosceles triangles. Now let us discuss about the circumcenters, basically the positions of the circumcenters as regard to an acute angle triangle, an obtuse triangle and a right angle triangle. For an acute angle triangle, the circumcenter always lies within the triangle. For an obtuse angle triangle, here the circumcenter lies outside the obtuse angle triangle. For a right angle triangle, the circumcenter lies exactly in the midpoint of the hypotenuse. If this is my 90 degree, this is my hypotenuse. The midpoint of the hypotenuse will be the circumcenter. This is another way of stating the Thales theorem, which I will be explaining to you in a short while. First, let us discuss about the circumcenter of an acute angle triangle. Here you have a triangle PQR, which is an acute angle triangle, whose circumcenter I have marked as C. I have not marked the perpendicular bisectors. I have marked the circumcenter, the meeting point of the perpendicular bisectors. And I have the circumcircle, and the circumradius is given by CP, CQ and CR. All three values are equal. So now this particular triangle is divided into three isosceles triangles. Whose base angles will obviously be equal. So if this is y, this angle is also y. If this is I have marked as z, this is also z. If this is x, this is x. Right? Now you know that in a triangle, the exterior angle is equal to the sum of the opposite interior angles. So now if I have a triangle which is marked in this way, and let me kind of try to replicate the diagram. Okay. If this is my triangle, I can say that this is my exterior angle. This particular angle will be equal to the sum of the opposite interior angles. So this particular angle will be equal to angle 1 plus angle 2. Similarly, you can see that there is a triangle PCR which is kind of similar in shape. So every triangle has to have an exterior angle. So I can say that this is the exterior angle for this particular triangle. So what is this value equal to? It will be equal to Z plus Z, which is equal to 2Z. Similarly, what about this angle? This is the exterior angle for this given triangle, which is PCQ. This particular angle will be equal to sum of the opposite interior angles, that is y plus y, which is 2y. So now what can I say about the angle QCR? This entire angle. The angle QCR is equal to 2y plus 2z or 2 into y plus z. Or I can also write it as 2 into angle P. This value. So in a circumcircle, when you have a triangle which is inscribed, I can say that this particular angle is equal to twice that of the vertex. Now I have here an obtuse angle triangle which is triangle PQR, and as I have mentioned, the circumcenter of the triangle lies outside the triangle. Now there is a circumcircle, so I have to have a circumradius. If I join the circumcenter to all the three vertices of the triangle, I get the value of circumradius. So CR is equal to CP is equal to CQ. Right? Now the base angles of an isosceles triangle are equal. So this is Y. This entire angle over here is a Y. Because I am considering the triangle CRP. Right? So if this is X, I know that because these two sides are equal, this whole angle is also X. Correct. Now, if I am considering the triangle PCR, PCR is this triangle. I know that this particular angle here is 180 degree minus this particular angle, angle PCR, 180 degree minus the other two angles, which is 2y. Similarly, for this triangle, if I am considering the angle QCP, this particular angle will be equal to 180 minus 2x. I need to find the value of this total angle. The value of this total angle will be the sum of first angle and the second angle. So, which is the sum of these two angles. So, I get it as 360 minus 2 into x plus y. Right? Or I can write it as 360 minus 2 into x plus y can also be written as 360 minus 2 angle P, because you can see that angle P measures x plus y. Right? Now, let me write it in a better way. This is equal to 2 into 180 minus angle P. So, you can see that in an obtuse angle triangle, this particular angle is equal to 2 into 180 minus angle P, whereas in an acute angle triangle, that particular angle is equal to 2 times this value. Okay, now let us move on to the right angle triangle and its circumcenter. Here I have a right angle triangle PQR. Okay, angle Q I have marked as 90 degree. As I have mentioned, the circumcenter lies in the midpoint of the hypotenuse. Hypotenuse is a side that is directly opposite to the 90 degree angle. So, let us make circumcenter. Now I have a circumcircle and I have a circumradius. So, these are my circumradius. Okay, all these three are equal. Now, this you can see that here this particular angle, because it is lying in a straight line, here it is 180 and here it is 180. Okay. Now, this particular statement of the circumcircle of a right triangle is another way of stating Thales theorem. Okay. Now, what is Thales theorem? Thales theorem basically states that the angle in a semicircle is a right angle. Or to put it in a more elaborate way, the angle that is subtended by or that is held by the diameter of a circle is always a right angle. So now let us see how the Thales theorem is related to this particular case of right triangle and the circumcenter. I have written the statement of Thales theorem. The angle subtended by the diameter is a right angle. Okay. So now, there is a random triangle over here which is inscribed inside a circle. AB is the diameter of the circle. Okay, diameter is the line segment that is passing through the center, touching the circumference. So, this is the diameter of the circle. This is the center. Tallis theorem states that the angle subtended by the diameter at any point on the circumference of the circle is a right angle or it is equal to 90 degree. So which means that this particular angle which they mentioned is a 90 degree. Suppose this is the angle that this particular diameter is holding over here. This particular angle is also 90 degree. At any point in the circumference, the angle subtended will be equal to 90 degree. That is Tallis theorem. Now let us go back to our circumcenter and how it is related to the Tallis theorem. Now, you know that whenever you have a circumcenter and a circumcircle, I say that circumcenter is the center of the circumcircle. So which means that the normal center and the circumcenter basically coincide. It's the same thing, right? So C is the circumcenter of a right angle triangle, and I said that the circumcenter of the right angle triangle is lying on the hypotenuse. So which means that the center of the circle is lying on the hypotenuse. So what does hypotenuse now become? Now hypotenuse actually becomes the diameter of the circle. Okay. Now this particular diameter of the circle is subtending an angle of 90 degree at any point in the circumference. Right? So actually when we mentioned that when we mentioned about the circumcenter of a right triangle and how the circumcenter lies on the center of the hypotenuse, we are in fact stating the reverse of the Tallis theorem. In short, Tallis theorem tells me that diameter holds an angle of 90 degree at any point on the circumference of the circle. Right? My concept of circumcenter says that the circumcenter of a right angle triangle, which is actually the center of the circumcircle, will lie on the hypotenuse, which means that my hypotenuse will turn into the diameter. Now we have concluded with the basic properties of the circumcenter of a triangle. So let me concise all the points. I have written it down on the whiteboard. So the first one is the definition of a circumcenter, which says it is a meeting point of the perpendicular bisectors of the sides of a triangle. Now I have mentioned that the circumcenter is unique, in which basically says that every triangle has got a single circumcenter and all triangles definitely do have a circumcenter. Now the third one, as you can see that the circumcenter provides three isosceles triangles as I have shown in the figure. The triangle ABC, you can see that OA is equal to OB is equal to OC. Now this particular triangle, this particular point called as a circumcenter is equidistant from each of the vertices. And it is the center, circumcenter will be the center of the circumcircle. Now you can see that I have drawn the circumcenter, mark the circumcenter of an acute triangle, obtuse triangle and a right angle triangle. For an acute triangle, the circumcenter lies on the inside of the triangle and its value BOC, the value of the angle BOC is given by 2 angle A. So similarly, the value of the angle AOC is given by 2 angle B and AOB is given by 2 angle C. Right? Now for an obtuse angle triangle, the circumcenter, which is O, lies outside the triangle. And the value of the angle BOC is given by 2 into 180 degree minus A. We have already done with the proof in the same session. So if you are having any doubts, you can mail me at the mail ID that is given below in the description box. And for a right angle triangle, the circumcenter lies in the midpoint of the hypotenuse. And I have also explained to you how it is related to the Tallis theorem. Here we have the first problem. So it is mentioned here that O is a circumcenter of triangle PQR. It is given that PQ is equal to QR and angle OPQ is equal to 15 degree. Find angle OPR. So as is the common norm, let us start with the diagram. Okay, so now I have drawn the diagram according to the specifications that is given in the problem. So we have a triangle PQR where PQ is equal to QR. So I can say that this side is equal to this side. So my triangle becomes an isosceles triangle. I can say that the base angles are equal. So what are the base angles? The base angle is this entire angle and this angle. Right? So if I am naming this angle as x, I can say that x plus 15 is equal to angle R. Okay. Now because O is the circumcenter of the triangle, I can join O to all the vertices. And I can say that each of these measurements are equal because they give the value of the circumradius. So I have three isosceles triangles whose base angles will always be equal. So if this is 15, I have this is also 15. If this is x, this part is also x. Right? Now, I know that this is also an isosceles triangle. And because that is an isosceles triangle, if this angle is y and the base angles are equal, this angle is also y. Right? So now, you know that. So I have marked all the angles. Some of them are in variables, in terms of variables. Others, here I have got constant values. Now I know that the sum of angles of a triangle is equal to 180 degree. So I have got angle P plus angle Q plus angle R is equal to 180. Or I can say or x plus y is equal to 75 degree. So the measure of angle R I have got as 75 degree. Right? We have already seen that because PQ is equal to QR, angle P and angle R are equal. So I can say that x plus 15 is equal to 75 degree. This is angle P. So what is the measure of x? X is equal to 60 degrees. Okay, so now we have the problem 2 here. Point O is the circumcenter of the triangle ABC and point O dash is the circumcenter of the triangle AOC. If angle ABO equal to 28 degree, find angle OO dash C. The diagram is already given to you along with the question. Okay, so now let us figure out how to find the measure of the angle OO dash C. Okay, so now angle ABO is given to be 28 degrees. O is the circumcenter of the triangle ABC. If O is the circumcenter, you know that the distance of the circumcenter of a triangle to its vertices are equal. So I can say that OB is equal to OC is equal to OA. I have written here. That gives me isosceles triangles. Since OB is equal to OA, I can say that base angles are equal. So if this is 28, this is also 28. Now I have OC is equal to OA. Because OC is equal to OA, I can say that the base angles, which is angle C, is equal to this angle. Let me mark it as x. Okay. Now I have got one more circumcenter in the same problem, which is the circumcenter O dash, which is the circumcenter of the triangle AOC. Now O dash is the circumcenter. Distance of the circumcenter to the vertices of the triangle AOC will be equal. So this side is equal to this, which is equal to this. So I can say that O dash C, O dash and O dash A, all the three measurements are equal. Okay. So you know that the sum of angles of a triangle is equal to 180 degrees. If this is 28 and this is 28, ABO forms a triangle. The sum of the angles is equal to 180 degree. If this is 28 and this is 28, what is the measure of this angle? This angle will be 180 minus 28 plus 28, 180 minus 56, which is equal to 124. Right? Now, this is 124. So, what is the measure of this angle, this entire angle? You can do it in two ways. This forms the exterior angle for the triangle ABO. This angle will be the measure of the sum of the opposite interior angles. Or I can say that this part forms a linear pair. So the sum of the angles is 180 degree. So 180 minus 124. This will give me 56 degree. right? Now, this is an angle of the triangle AOC. I have got the measure of this angle. I know that OC is equal to OA, right? So, triangle AOC is an isosceles triangle. Isosceles triangle, you know that the base angle, this and this are equal. So, because the sum of angles of a triangle is 180 degree, this plus this will give me, so this is X and this is angle C. I can say that X plus angle C plus 56 degree should give me 180 degree. And X and angle C, they are equal. So I can write it as 2x plus 56 is equal to 180, or x is equal to 180 minus 56 by 2, which will give me a value of 62 degree. Or I can say that here the measure is 62 degree. Here also the measure is 62 degree. Okay. Now, for this triangle, O dash is a circumcenter. We know that for an acute angle triangle, whenever we have the circumcenter, inside of the triangle, the value of this particular angle will be equal to 2 angle A. Or I can say in this case, it is 2 angle X. Or this particular angle will be equal to 2 into 62, which is equal to 144 degrees. We have the third problem regarding the circumcenter. In the triangle ABC, O is the circumcenter. OF, OD and OE are the perpendicular bisectors of the sides AB, BC and AC respectively. If OF is equal to 3 units, AF is equal to 10 units. Area of the triangle ABC is 116 square units. Find the area of CDOE. So now this is a sum wherein they are not asking us to find any angles. We have been given the side measurements and we need to find the area of a particular portion of the given triangle. So before I proceed with the sum, I will redraw the diagram so that I can do my working on it, right? I have redrawn the diagram. We have the triangle ABC and the measure, and it is mentioned OF, OE and OD and OE are the perpendicular bisectors. So I have marked them to be perpendicular. It is also given that OF is equal to 3 units and AF is equal to 10 units. The area of the triangle ABC is given to be 116 units, which is the area that we need to find. CDOE is the area that we need to find, which we can see that it is divided into 2 parts. This is one part and this is the other part, right? So let me mark this part as 1 and this part as 2. Okay. Now let us figure out what are the measurements that we can actually get from this particular information that is given to you regarding this diagram. Okay. We know that this is 10 units and this is 3 units. So this is a 90 degree. This is also 90 degree. So what kind of triangle does this become? It becomes a right angle triangle. Whenever you have a right angle triangle, the first thing that goes through your head is, can I apply the Pythagoras theorem? Yes, we can, to find the measure of this particular side. Okay. Since this is 90 degree, this has to be my hypotenuse. Hypotenuse square is equal to base square plus altitude square. So what do I get here? 10 square plus 3 square. So this particular measurement will be under the root. I get this measurement as a root 109. Okay. So the measure of OA is equal to root of 109. Now, you know that the circumcenter is equidistant from the vertices because the distance between the circumcenter and my vertex will give me the circumradius. So circumradius is supposed to be equal. So if this length is equal to this length is equal to this length, right? So what I get is, this is root 109. This also has to be root 109. And the measure of this particular line segment, which is given by OB, is also root 109. Okay. What else can I find from this particular diagram? AB has a perpendicular bisector OF. A perpendicular bisector is a line segment that divides a line into 2 equal segments at an angle of 90 degree. So if this is 10 units, this also has to be 10 units. Okay. Now, I am not able to find any other sides of the triangle. Now what other information is given to me? It is given that the area of the triangle ABC is 116 square units. Now whenever the area of a triangle is given, the first thought that goes through our head is, can we apply the formula half BH, or can we apply the Heron's formula which includes the semi-perimeter. Now in this case we cannot apply the formula half base into height, mainly because we don't know the base values or we don't know the entire height values. The only base that we know is that of the side AB. Okay, so we discard that idea and then we think about the Heron's formula. Even Heron's formula is not applicable because in order to find the value of the semi-perimeter, we need the measure of the sides. That is also not working. So I need to figure out how to find the value, how to find the area of the triangle ABC, because the value of the area is given to me. As I can see that this particular triangle ABC is divided into many smaller triangles. Okay. Now, this is one triangle. This is one triangle. What can I say about these two triangles? I can say that the area of this triangle will be given by half base into height, which is half 10 into 3, right? Which is 15 square units. Am I right? I can see that there is the same area of this triangle also, which is half 10 into 3. So I can say that the area of this as well as the area of this is the same, or in order to find, when I am adding up the area, I just need to take the double of one part. Right? Okay. Now, same will be the case of this triangle and this triangle. Right? Similar will be this and this triangle. So let us write it down. The area of the triangle ABC is given by the sum of all these small triangles. If I am writing, this is 1, this is 2, this is 3, this is 4, this is 5 and this is 6. So it will be the area of 1 plus 2 plus 3 plus 4 plus 5 plus 6. Now I know that the area of 4 and 5 is the same. So I can write it here as 2 times 4. Correct? So I am getting area of 2 times the first part, 2 plus 2 times the second part, plus 2 times the fourth part is equal to 116. Or if I take this 2 outside, 2 times the area of 1 plus 2 plus 4 is equal to 116. $58. Is there any area that I know in this? I know the area of 5 and I know the area of 6, which is 15 plus 15, which gives me 30. So I write area of 1 plus 2 plus 4, because we already accounted the 2 over here. So I will write it as 15 is equal to 58. Or area of first part plus area of the second part is equal to 58 minus 15, 63. What was the area that we needed to find? It was the area of CDOE, which we split into 1 and 2. So 63 square units would be my answer. Okay, so part 1 and the part 2 sessions of this particular class is over. So we dealt with the definition and the properties of circumcenter with respect to a triangle in the part 1. We did a few sums regarding the circumcenter in part 2. So now we move on to part 3, where we treat circumcenter inside a triangle as having coordinates in relation to coordinate geometry. When we say coordinate geometry, the particular triangle have coordinates, the circumcenter have coordinates. So this particular part of the circumcenter class is meant for people who are already conversant with coordinate geometry. Right? So let us start with the class. When I talk about coordinate geometry, you know that every point in a plane can be represented by two coordinates, which is x coordinate and the y coordinate. So when I am saying that a triangle has a circumcenter O, we need to understand that A, B and C, the three vertices of a triangle, can be represented in terms of coordinates, and the circumcenter also can be represented in terms of coordinates. Now, one of the common questions or one of the common problems that I have come across in this circumcenter as related to coordinate geometry in competitive examinations is that we are asked to find the coordinates of the circumcenter when the coordinates of the three vertices of the triangle are given. Now, there are two ways of going about this problem. Now, it is left to the student to analyze both the methods and figure out which one is easier. So, let us put proper numerical values to the coordinates and try to figure out the coordinates of the circumcenter. Now, I have given proper values for the coordinates of the three vertices. This A vertex is given by 1, 3. B vertex is given by 0, 4 and the C vertex is given by -2, 5. You are asked to find out the coordinates of the circumcenter. This particular sum was taken from a website. I don't exactly remember the details. So, how do we find the coordinates of the circumcenter? Okay. Now, in order to find the coordinates of the circumcenter, we need to know the property of the circumcenter that can be applied here. You know that the circumcenter is equidistant from all the three vertices, which means that these three lengths are equal. In coordinate geometry, how do you find the length of a line? We use the distance formula, which is x2 minus x1 the whole square plus y2 minus y1 the whole square under the root. So, let us start finding out the value of the particular numerical value of the length OA, OB and OC. Okay, so now I will use the distance formula in order to get the length OA, OB and OC. The distance formula is x2 minus x1 the whole square plus y2 minus y1 the whole square. It will give me the square of the distance where x1, y1 and x2, y2 are the two coordinates between which we need to find the distance. I have written down OA square, OB square and OC square using the distance formula. And now in order to start finding the value of the unknown x and y, I will start by equating OA square and OB square first. Now, let me open the bracket here. I get x square minus 2x plus 1 plus y square minus 6y plus 9 will give me x minus 0 the whole square is x square plus y square minus 8y plus 16. Let me cancel out the common factors. And now let me transpose the variables to one side and the constants to the other side. So I get minus 2x minus 6y plus 10. I'll transpose minus 2x plus 2y should give me 6. Right? Now, this is my first equation. Now, you know that I have got one linear equation in two variables. In order to get a consistent answer, I need one more linear equation. So, in order to get that linear equation, I am going to equate OA square and OC square. You are free to equate OB square and OC square also. So, let me equate OA square and OC square and let us see what we are getting. So, now I have equated OA square and OC square and I have gotten the linear equation minus 6x plus 4y is equal to 19. Now, let us figure out how to find out the values of x and y. Now, you have two linear equations which we can use to find out values of x and y. You must be familiar with how to solve a linear equation. Here, I know that I need to cancel out one of the variables. In this case, I have to multiply the first equation with a 2 in order to get 4y there. So, I will multiply the first equation with a 2. I get minus 4x plus 4y is equal to 12. Minus 6x plus 4y is equal to 19. This is my second equation. I will cancel out 4y term. So, I subtract both the equations. I get 2x is equal to minus 7. Or I get the value of x is minus 7 by 2 or minus 3.5. Now that I have gotten the value of x as a minus 7 by 2, I need to substitute it in one of the equations in order to get the value of y. So after substituting the value of x in this particular equation, I have gotten the value of y as a minus 0.5. So here we have used the distance formula in order to figure out the coordinates of the circumcenter. Now there is another method without using the distance formula by which we can find out the coordinates of the circumcenter. But in order to apply that particular method, you should know about how to form the equation of a line and about the slope and what is the slope form of the slope equation of a line. Here I have taken the same triangle whose coordinates were given to you in the previous question, and we will try to find out the circumcenter using the slope equation of a line, right? Now, in order to start with this method, we know that circumcenter is the meeting point of the perpendicular bisectors. So, right, perpendicular bisector means this particular point should be the midpoint of this line AC. This is the midpoint of BC and this is the midpoint of AB, right? So, I will mark it as X, Y and Z. So, what are the coordinates of Z? What are the coordinates of Y and what are the coordinates of X? In order to find the coordinates of X, Y and Z, I have applied the midpoint formula, which is x1 plus x2 by 2, y1 plus y2 by 2, gives me the midpoint of a line joining the points x1, y1 and x2, y2. So, in order to find the midpoint of AC, I will apply the same formula and I have got these coordinates, the coordinates of Y and the coordinates of Z. Now, you should know the slope equation of a line in order to proceed with this method. The slope equation of a line is given by y minus y1 is equal to m into x minus x. Okay. Circumcenter is the meeting point of three lines which are the perpendicular bisectors from the sides. Yes. So, in order to get the coordinate of the circumcenter, I need to get the equation of only two lines. I can solve them and I can get the value of the coordinates of the circumcenter, which I can actually put it in the third equation and see whether it is an actual value which I got, if I have made a mistake. But to find out the value, I need only the equations of two lines, any two lines. Okay. My task is to find out the equation of this line and this line. You can take this line and this line or this line and this line. It is absolutely left to the freedom of the student. I will be taking OZ and OX. Now, in order to find the equation of OZ, it is y minus y1 is equal to m into x minus x1. Now, I know that is y minus 4 is equal to m into x plus 1 by 2. I have an unknown factor here, m, which is the slope of this particular line OZ. Now, what is slope? Slope is actually the difference between the y coordinate and the x coordinate. Now, my problem is because I do not have the y coordinate, y2 and y1 I do not have, and x2 and x1 I do not have. I have only one coordinate here. The other coordinate is unknown, xy. So, how do I find the slope of this particular line? This particular line is a line which is perpendicular to the side AB. Sorry, AC. Correct? The product of the slopes of two perpendicular lines will always be equal to minus 1. So, if I have got line 1 which is perpendicular to line 2 and they have a slope of m1 and m2, the product of slope m1, m2 will be equal to minus 1. Okay. So, I know that the slope of AC multiplied by the slope of OZ will be equal to a minus 1. So, how do I find the slope of AC? The slope of AC is given by the difference of the y coordinates divided by the difference of the x coordinates. So, what is the slope of AC? That is 5 minus 3 divided by minus 2 minus 1, which is 2 by minus 3. So, what is the slope of OZ? The slope of OZ is given by the reciprocal of this one, because the product of this is equal to minus 1. So, the slope of OZ is a 3 by 2. Now let me apply the slope equation of a line, which is y minus y1 is equal to m into x minus x1. I know the value of y1, I know the value of x1, I know the value of m also. Okay, so when I write down the equation, what do I get? So here I have written down the equation of the line OZ, y minus y1 m into x plus 1 by 2. Okay. Now I will simplify this equation and I will write it as y minus 4 is equal to 3 by 2x plus 1 by 4. Okay. Or I get, after transposing, I will get it as so my equation is 3 by 2x minus y is equal to minus 19 by 4. That is the equation of my line OZ. Okay, this is my first equation. Now I need to find out the equation of the line OX. In order to find the equation of the line OX, the first step was to find the midpoint of the line AB, which I have already found as 1 by 2, 7 by 2. In order to find the equation of the line OX, I will apply the same formula, y minus y1 is equal to m into x minus x1. I know the value of y1 and x1, which is 1 by 2, 7 by 2. I need to get the value of m, which is the slope of OX, which I can get by getting the slope of AB. Right? As you can see, I have written down the equation of the line OX. I have found out the slope of AB. Then I have found out the slope of OX. I have applied the equation of the line y minus y1 is equal to m into x minus x1. I have simplified and I have gotten the equation as an x minus y is equal to a minus 3. Now I have got two equations of the line OZ and the line OX. The first one is 3 by 2x minus y is equal to minus 19 by 4, which is my first equation. And the second equation is x minus y is equal to minus 3. Let me solve the equation. I will subtract because I have a y term which is common with a negative sign. So what do I get? I get 3 by 2x minus x is equal to minus 19 by 4 minus 3, which gives me plus 3. Right? So here I will get it as 1 by 2x is equal to minus 7 by 4. Or I can say the value of x is minus 7 by 2 or minus 3.5. If you recollect, this was exactly the same value for the x coordinate of the circumcenter which we did by the distance formula. Substituting this value of x minus 3.5 in any of these equations, you will get the value of y as a minus 0.5. Here I have written down the two different methods that we use to find out the coordinates of the circumcenter when the vertices of the triangle are given to you. The first one is the distance formula and the second one is the slope equation form of a line which we use to find out the equation of the perpendicular bisector. We find out the equation of the two perpendicular bisector by using the midpoint and by using the slope, and then we use them to solve to find the circumcenter. In the first case, we used the distance formula and we used two sets of equations in order to find out the coordinates of the circumcenter. Now, the reason for using the distance formula was that in a triangle, the distance of the circumcenter to the vertices, they are equal. The reason for using the slope equation form of a line was that the circumcenter is the meeting point of the perpendicular bisectors. Before you proceed with any sum or any method, please understand the reason why we are using that particular method. Choose whatever is best convenient for you and proceed with that. Now we are at the end of our session on circumcenter and the circumcircle. So before I wind up my class, I will give you an additional formula regarding the circumradius r. So I have marked the circumradius r. Circumradius r is equal to ABC divided by 4 times A. So what is ABC? A, B and C are the measures of the sides of the triangle. So they are the measures of the sides of the triangle. And what is A? A is the area of the triangle. this is an additional formula for circumradius. Before leaving the class, I will give you a sum that has come in one of the Olympiads regarding the circumcenter. Though the sum looks extremely complex when you read through the sum, you will see that the solution is very simple. I would rather ask you people to try out the sum once before looking at the solution. This particular question I have taken from the European Mathematical Olympiad of 2012. Now it is given that let ABC be a triangle with the circumcenter O. D, E and F are points on the sides BC, CA and AB in such a way that DE is perpendicular to CO and DF is perpendicular to BO. Okay. Now let K be the circumcenter of the triangle AFE. Prove that the triangles DK and BC are perpendicular. So I have the diagram was also given in the question. So I have tried to copy down the diagram as neat as possible. So have a look at it. As you can see, I have drawn the triangle ABC. The circumcenter is O. I have joined O to each of the three vertices A, B and C. So I have got OA, OB and OC. Now I have marked the points D, E and F on the sides BC, AC and AB. And DE is perpendicular to OC and DF is perpendicular to OB. Okay. Now I have marked the circumcenter of the triangle AFE, which is K, and I have joined K to each of the three vertices. So I get the lines KA, KF and KE. Now the question is to prove DK is perpendicular to BC. So which means this particular angle is 90 degree. Okay. So this is angle A. Now ABC is a triangle, O is a circumcenter. So what can you say about the measure of angle BOC? It's a scalene triangle. It's an acute angle triangle. So the measure of angle BOC will be 2 angle A because of the property of the circumcenter which we have already discussed. Right? Now OB is equal to OC. So OBC becomes an isosceles triangle. So what can I say about the measure of angle OBC and angle OCB? Both of them are equal because they are the base angles of an isosceles triangle. So I can say angle OBC is equal to angle OCB. Right? So from this triangle, if this is 2 angle A, we can find out the measure of angle B and angle C. So I have written down the measure of angle OBC and angle OCB. It is 90 minus angle A by using the angles because sum of angles of a triangle is equal to 180 degree. It's the simplest one. Now let us see which other angle I can find out. Now I know that triangle AFE, K is a circumcenter. So what is the value of the angle FKE? It will be again equal to 2 angle A. Am I right? Okay. Now in the same triangle, I also know that KF is equal to KE because they form the measure of, they form the distance from the circumcenter to the vertices of the triangle. So KF is equal to KA is equal to KE. So since these two sides are equal, I can say that the base angles are equal. So this also gives me 90 minus A. And this also gives me 90 minus A. Okay, so now let us consider this particular triangle. Okay, in this particular triangle, this angle is 90 degree. This angle is 90 minus A. So what is the measure of this angle? You can use the sum angle property of a triangle. So you get the measure of this angle as angle A. Okay. Similarly, this angle also you get it as angle. Right? At the point D, you know that the sum of angles above the line, the total angle is equal to 180 degree, which means angle A plus this particular value of the angle is equal to 180 degrees. So what is the measure of this particular angle? This should be equal to 180 minus A. Minus 2 angle A, my bad, sorry. Right? So I have got the measure of this particular angle as 180 degree minus A. Now let us look at the quadrilateral KFDE. In this particular quadrilateral, you know that the angle K is 2 angle A. we found out that the angle FDE is equal to 180 minus 2 angle A. So what is the sum of angle K and angle D equal to here? The sum is equal to 180 degree. When the opposite angles of a quadrilateral, the angles add up to 180 degrees. What kind of a quadrilateral is that? It is a cyclic quadrilateral. So we can apply the properties of a cyclic quadrilateral to this particular four-sided figure. So KFDE becomes a cyclic quadrilateral. In a cyclic quadrilateral, which means that the quadrilateral can be put inside a circle. So if I have a cyclic quadrilateral, you can also apply the properties of circles into this particular diagram. So I have KFDE as a cyclic quadrilateral. Now you can see that KFE and KDE are angles in the same segment. So KFE and KDE are angles in the same segment. So I can say that KDE is the same measure as KFE, which is equal to 90 minus A. So when I am adding the angles over here, 90 minus A plus A will give me 90 degree. So I can say the lines DK and BC are perpendicular. Now this is a problem wherein the solution was found in a very simple method by finding out the measures of a few angles by using the basic theorems. But yet it was asked in the Maths Olympiad mainly because it requires a calm state of mind to solve such a problem. If you have any more doubts in this particular concept or any sum that I have discussed, or in case you want more worksheets regarding Circumcenter, please feel free to mail me at the mail ID given below in the description box. Bye.